Well, before we look at some more tricky examples and some exam questions, let's just have a quick look at, let's go back to the moon just to apply these equations and just to see what's going on. So, well, remember, when we studied the moon and looked at its circular motion, we found its orbital speed, and we discovered that its orbital speed was about 1 kilometre per second, 1030 meters per second. We found that its angular velocity was 2.66 times 10 to the minus 6 radians per second, if you remember. And remember that we were given the radius, we knew the radius is 3.85 times 10 to the 8 meters. Well, some more data we need is the mass of the moon, and if we write that as mass of the moon, well, the mass of the moon is 7.35 times 10 to the 22 kilograms. So using that, we should be able to find, first of all, what is the centripetal acceleration of the moon in orbit around the Earth. So, well, if there's the Earth and there's the moon kind of orbiting around, well, we can just use either A equals v squared over r, or we can use A equals omega squared r. So, well, let's use A equals v squared over r. Well, if we plug that in, we get 1030 squared over 3.85 times 10 to the 8, and that gives us a centripetal acceleration of 2.76 times 10 to the minus 3 meters per second squared. So there we have it, simple as that. Perhaps more interesting is to look at the corresponding force. Well, we just plug in F equals ma, or mv squared over r, so we just multiply that by the mass of the moon. So, well, the mass of the moon we've already got, so it's 7.35 times 10 to the 22 times that acceleration, and that gives us 2.0 times 10 to the 20 newtons. So now that's quite interesting. That's telling us the size of the force, the centripetal force, which is making the moon accelerate in that way, which is making the moon move in a circle around the Earth. Well, we know, we've already decided that that force must be pointing towards the Earth. So we've answered this question, and we know the direction is towards the centre of the Earth. What provides it? Well, we know that, don't we? We know that it's gravity that's pulling the moon towards the Earth. And that kind of ties in quite nicely, because when we stated before that a centripetal force always acts towards the centre of the circle, this is a nice example which kind of demonstrates that that's physically true. We can see, we know that the gravitational force between the moon and the Earth is acting towards both bodies, that the Earth is pulling the moon directly towards its centre. So that kind of corresponds quite nicely. And later on in gravity and orbits, topic later on, well, there's another way to derive that force using Newton's law of gravitation, and at that point we can confirm that that is the force due to the force of gravity. But for now, we've found the centripetal force because we know the speed it's going in its orbit, and we know that that's that huge value. We could, of course, done it by m omega squared r, and exactly the same, so 7.35 times 10 to the 22, and if you punch that in the old calc, the old machine, then you can confirm that that will give us the same answer, m omega squared r, and times 10 to the 8. So good, well, that's just for starters. In the next clip, we're going to look at some more tricky examples where we have to kind of establish what's providing the centripetal force.